are related to the other graph. Related to the other graphs. Graphs are discrete structures consisting vertices and edges. Connect these vertices. Graphs can be used to solve many types of problems, such as finding number of colors needed to color the regions of a map, computing the number of different combinations. Definition. 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 A graph written. A graph. A graph written as graph is G V comma E. V means vertices, E means edges. Consists. Consists. A finite set of vertices. Finite set of vertices. Finite set of vertices. Vertices V. Also called nodes or points. A finite set of edges E. A finite set of edges. Edges. Edges V. Also called arcs or lines. Hold on. A mapping F from the set of edges. A mapping a mapping F. A mapping F from the set of edges from the set of edges from the set of edges E to the set of vertices. Set of vertices. Set of vertices. V such that E. V such that V such that E belongs small E belongs to capital E. Is associated with a pair of elements. With pair of elements. Pair of elements. Pair of elements of E. Of V. Of V. In this graph called undirected graph, each edge, say E, is associated with the unordered pair of vertices Vi, comma Vj, where Vi, Vj are called the end vertices of edge. Next definition. Next definition. A multigraph GV, comma V. A multigraph GV, comma V. V, comma E. GV, comma E. Consists of a set V of vertices. Consists that set V of vertices. V of vertices. A set E of edges. A set E of edges. E of edges. And a mapping F from E to. From a mapping F from E to. From E to U, comma V. U, comma V. Such that U, comma V belongs to capital V. U, comma V belongs to capital V. And U is not equal to V. U is not equal to V. They adjust E1, Ei, Ej. Adjust Ei and Ej are called multiple multiple or parallel edges if F of Ei, F of Ej. An edge joining a vertex itself is called loop. Yeah, a graph is said to be simple if it has no loops and multiple edges. Since loops are not allowed in a multi-graph, we introduce a pseudo-graph, which is more general than multi-graph and allows loops. Okay, example. V1, V2, V3. V1, V2, V3, V4. Simple undirected graph. Simple undirected graph. V1, V2, V3, V4. Simple and directed graph. And hence directions are there, no? That simple and directed graph. Directed graph. Next. V1, V2, V3, V4. Multigraph. Multigraph. Pseudograph. V2, V3, V4. This is known as pseudograph. E silent. SE. Pseudograph. Pseudograph. Pseudo- Definition. A graph whose vertex set V is finite, but edges set E is empty is called a null graph. A special type of null graph consists of only one vertex and hence no edges. G1, 0 is called a trivial graph. Following is the vertex V1, V2 with a trivial graph. V1, V2, V3, V4, V5. This is known as trivial graph. Trivial graph. Trivial. Incident and the degree of a vertex. Definition. Incident and degree of a vertex. Incident and degree of a graph. Let G become a E. Become a E. V an undirected graph. Non-directed graph. V1 belongs to capital V. The degree of vertex Vi of degree of vertex Vi, vertex Vi, denoted by degree of Vi, denoted by degree of Vi. Degree of is the number of edges. Number of edges incident on Vi, on Vi, plus twice the number of loops, number of loops, number of loops at Vi, at Vi, if any. If G is simple graph, simple graph, then degree Vi, degree Vi is simply the number of neighbors number of neighbors to improve the number of neighbors. Surrounding Vi, surrounding Vi, Vi, surrounding Vi. Definition. A vertex is said to be even or odd according as its degree is an even or odd number. A vertex of degree 0 is called an isolated vertex. It follows that an isolated vertex is not adjacent to any vertex. A vertex is called pendant if and only if it has degree 1. Consequently, a pendant vertex is adjacent to exactly one other vertex. 0. 0. 0. With the definition. The sum of degree of all vertices. the sum most important, the sum of the sum of the degrees of all vertices of all vertices all vertices all vertices in a graph is in a graph is twice the number of its edges, twice the number of twice the number of its edges. Its edges. Oh, let G be a graph with n vertices, n vertices. N vertices n vertices V1, Vn and E edges E edges. Since every edge is incident, incident, incident with the two vertices. Two vertices. It contributes 2 to the sum of the degrees. Sum of the degrees. Sum of the degrees of the vertices of G. Vertices of G. Hence the sum of the degrees degrees. Sum of the degrees of all the vertices vertices all the vertices in the graph G. The graph G is twice the number of edges in G. number of number of adjacent G. G adjacent. That is sigma I equal to 1 to F. Degree VI equal to 2E equal to 2E. This result known as the first theorem. Result known as the first theorem. First theorem. And graph theory is often graph theory is often called the handshaking lemma. Handshaking lemma. Handshaking lemma. Since it tells that it tells that tells that several people shake hands, several people, several people shake hands, shake hands. The total number of hands shaken must be total number of hands. Hands. Number of hands shaken must be shaken. Even how precisely, even as precisely precisely. Two hands are involved in each handshake. Two hands are involved. Two hands are involved in each handshake. Each handshake. Each handshake. The following theorem is established using this lemma. Following theorem is expressed usually using lemma. 0. 7.3.6. 4 mark. 2 dash. 7.0. 7.4.3. 7.4.3. 10 marks question. Wrong answer type 4 mark. Next. Complete regular and bipartite graphs. Complete graph. Complete regular bipartite graph. Graph. Bipartite graph. So definition. Complete graph. Definition. A complete graph of n vertices. A complete graph. Graph. N vertices. N vertices. N vertices. Denoted by Kn. Denoted by Kn. Is a simple graph. Simple graph. A simple graph that contains exactly exactly one edge between each pair of between each pair of distinct vectors. Distinct vertices. Distinct vertices. In other words, in a complete graph, every vertex is connected to is connected to connected to every other vertex. Every other vertex. every other vertex, and every pair of different vertices, every pair of pair of different vertices, vertices, vertices are adjacent. Are adjacent. Regular graph. Definition. A graph GV comma is said to be K regular or regular of degree if every vertex of G has degree K. In other words, a graph is regular if every vertex has the same degree. Next, bipartite graphs. A simple graph GV comma E. Simple graph. Graph GV comma E is called bipartite. Bipartite. Partite. Bipartite. Since its vertex since its vertex we can be partitioned into partition into partitioned into disjoint sets V1 and V2 disjoint sets V1 and V2 V1 and V2 such that V1 and V2 such that every edge E in G every edge every edge E in G connects a vertex in V1 V1 to a vertex V2 vertex V2 and no edges edge in G no adjoint chain. Cannot say the two vertices. Say the two vertices in V1. V1. Or two vertices V2. Or two vertices V2. Definition. Complete bipartite. The complete bipartite graph denoted by Km, N is the graph that has its vertex set partitioned into two disjoint subsets, M and N, all of order M and N vertices, and there is an edge between every vertex of M to every vertex of N. For standardization, I will assume M is less than or equal to N. Next, weighted graph. Cycle graph. A graph consists of n vertices v1, v2, etc. Vn, and where edges v1, v2, v2, v3, etc. En minus vn. Vn comma v1 is called cycle graph. It is denoted by Cn. N is greater than or equal to 3. So wheel graph. So if an additional vertex is added to the cycle graph, Cn, N is greater than or equal to 3, and this new vertex is connected to each of the n vertices in Cn by new edges. The resultant graph is called wheel graph. It is denoted by Wn, wheel graph for n equal to 3, 4, 5, 6, 1. So, weighted graph definition. A graph G, V, comma E is said to be weighted graph if a positive real number W called Y weight is associated to each of its edges equal to Vi, comma Vj belongs to E. Such weight may represent the length of the road from V1 to Vi to Vj at the time taken to travel on this road from Vi to Vj or the cost incurred in traveling from Vi to Vj, etc. Check your purpose and walks, paths, and a circuit of a graph. Walks, walks, paths, paths, and a circuit in a graph. Circuit in a graph. G, V, comma E is undirected graph. A walk in G is finite alternating sequence of vertices and edges, beginning and ending with vertices, such that each edge is incident with the vertices preceding and following it. In a walk, no edge appears more than once, but a vertex may appear more than once in a walk. The first and the last vertices are called the terminal vertices. A walk is also referred as a trail. Next definition. G, comma E is a undirected graph. A path is called open walk. A path is open walk through an sequence V0, V1, etc. V1 of vertices in G, each adjacent to the next in which no vertex appears more than once. In other words, a path does not intersect itself. Such a path is known as elementary path. secure progress, and model exam summary exams. Okay. Today we discussed Unit 7. Tomorrow, Unit 8. So one more definition we'll discuss. If it is possible, for definition. Let G V come up. G comma U comma E. B, an undirected graph. Undirected graph. A path is an open walk. Path, an open walk. Path is an open walk through AN sequences. AN sequences. AN sequences. V0 comma V1. Etc. Bn of vertices in G. Of vertices in G. Each adjacent to the next. Adjacent to the next. To the next. In which no vertex appears. Vertices. More than once. More than once. In other words, a path does not intersect itself. Such a path is known as elementary path. The number of edges in path is called its length. So, thank you very much. Today we discussed 7th unit, tomorrow 8th unit. Okay, I'm leaving.